Now let's see one example. In general, let's talk about random variables in a shortcut first. See, if you want to observe what is happening here, simply put, we'll have a sample space, right? And then random variable is nothing but it will take each point in the sample space and it will map it to a number, some real number, right? In some case what happens is random variable, depending on what type of values this random variable can take, we are going to define it as discrete as well as continuous. I'll show you those examples later. And then what happens is with some probability random variable will get the values in this real number set. And now when I assign these probabilities to these numbers, then that is called as probability distribution. Got it? So simply put, there will be sample space and a random variable will take each point in the sample space and will give us some number, some real number. And then if you try to find out what is the probability with which each number in this set can occur, then that is called as probability distribution. And random variables can be of various types, discrete and continuous. I'll show you the examples later. Now we shall see. So what is that I wanted to prove is, once you find out all these probabilities, if you add them all up, then the sum is going to be 1 always. For example, in the earlier example, what is the probability tossing a coin 2 times? Let's say x is the variable which is counting the number of heads that might occur when we flip a coin twice. X can be 0 or x can be 1 or x can be 2. Now the probability that x can be 0 is 1 by 4, the probability that x can be 1 is 2 by 4, and the probability that x can be 2 is 1 by 4. When I add them all up, the sum was 0, right? And similarly we have even seen the other example. In that also, when we sum all the values, then we got it is the sum of all probabilities as 1. Let me show you one more example in which the number of points are not actually finite, but they are countable. I hope you know the difference between finite and countable. If you didn't know that, please watch the TOC videos where we have discussed about finite sets, countable sets, uncountable sets, all those. Okay, so for now let's see. Okay, if you want to know what is countable in simple ways, if you can put a set in one-to-one correspondence with the set of natural numbers, then they are called countable. Okay, fine. Now let us say we are conducting an experiment in which the probability, I'll be flipping a coin first, and the probability of getting a head is P. Okay, what is it? Probability of getting a head is P. Now what does it mean? Probability of getting a tail will be 1 minus P. If P happens to be 0.5, then the coin is fair. If P is not 0.5, then the coin is unfair. But we need not worry about what type of coin it is already given. So the probability of getting a head is P and the probability of getting a tail is 1 minus P. Then what I do is, the experiment is about, I'll keep on flipping the coin until I get a head. I'll keep on flipping it till I get the first head. Let us say this is the experiment. Then the question is, now let's try to define the random variable. Okay, let's say random variable capital N denotes the number of times I'll have to flip the coin so that I can get the head. Are you getting this? See, experiment is simple. I have a coin and the probability of getting a head is P and the probability of getting a tail is 1 minus P. This is very easy, right? And the next step is, experiment is simply flipping the coin until I get a head, and let capital N denote a random variable which indicates the number of times I'll have to flip the coin until I get the first head. Okay, now what are the various values possible for N? N can be 1, which means sometimes when I flip the coin, immediately I can get the head in the first try, or N can be 2, which means first time there might be a tail and second time there may be head, or N can be 3, which means tail head, like that. Therefore N can take any value till infinity. Now what is the probability that we want to assign to each value of N? Now let's see this. Probability of capital N equal to 1. What do you mean by this? This is nothing but the event, if you flip the coin, if first time itself if you get the head, then N will take the value 1. So what is n here? The number of times we will have to flip the coin in order to get the head, right? So n equal to 1 means directly I flip the coin and I got a head. So whose probability is p, isn't it? Similarly, what about p of n equal to 2? What does it mean? Now in order to get the head for the first time, I'll not get it for the first time, but I'll get it in the second time, which means first time I'll get a tail and second time I'll get a head. And we know that these are independent events and it can be written as p of t intersection h, and since they are independent events we can multiply them, which means probability of getting a tail followed by a head equal to probability of getting a tail into probability of getting a head, because they are independent events. When I flip a coin 2 times, both times the outputs are independent, they are not going to depend, right? Therefore it is equal to probability of getting a tail, which means 1 minus p, into probability of getting a head, which is p. And similarly, p of n equal to 3, what does it mean? Now I'll be getting the head in the third trial, not in the first one, not in the second one. Therefore this event is same as getting a tail followed by getting a head, which is nothing but 1 minus p into 1 minus p. Are you getting this? This 1 minus p is related to getting the tail followed by p, right? And similarly so on. What is p of capital N equal to n? So small n. Now what is the probability that you get the head in the nth time, where small n is some number? Then what can you say about it? P of tail so on, n minus 1 times you should get tail followed by a head, so which is nothing but 1 minus p power n minus 1 into p. Got it? Now when I sum them all up, so what is the sum of all this? Sigma small n equal to 1 to infinity p of capital N equal to n. So what do I mean by that? I'm just adding them all up from 1 to infinity, because in this experiment I don't know whether I'll get a head or not, right? I'll keep on flipping it. So when I sum them all up, then what is it? It is p plus 1 minus p into p plus 1 minus p square into p plus 1 minus p cube into p plus so on infinity. Now what is this? This one is equal to, if you pull out p as common, 1 plus 1 minus p plus 1 minus p square plus so on, right? So if you see this is infinite geometric progression with a common difference of 1 minus p, right? And we know that in infinite geometric progression the sum of all terms is going to be a by 1 minus r in case r is less than 1, and in this common difference r 1 minus p is of course less than 1. The reason is always the probabilities are less than 1, right? See, probability of getting a head and this is the probability of getting a tail, 1 minus p, that is obviously going to be less than 1, because sum of these two is going to be 1, isn't it? Therefore it is going to be a into 1 minus 1 minus 1 minus p. Then what is this? It is going to be 1. Got it? Therefore we have again seen that even if the number of values we are going to take is infinite, when I sum them all up, the probabilities is going to be 1 for any random variable. You can we'll always get this. With examples I'll show you all this. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.